Hello, this is Len from your Math 182 class. Uh, and today I'm solving the problem number 9 from 8.3 homework. And what I want to do is that first I want to determine whether this is convergent or divergent, whether this series is convergent or divergent. And when I think about this, when I look at this, a method that comes to my mind is the integral test. So this is a separate paper. And I have the integral test right here, or as I call it, CPD, easier to remember. And that the categories or the requirement for the integral test is whether it's a continuous from 0 to infinity, positive, and eventually decreasing. And that when I find the graph of this one using f of x format, is that I see all the requirements are met, which means we're able to apply this condition here. So we'll come back to the condition in just a minute. But first, let's see the steps of how to solve this problem. So, since we can use the integral test, so we let's set this as an integral of f of x. So I need to rewrite this in a limit format. As n approaches, rather, t approaches infinity, we have n is equal to 1. We replace the infinity with t over here. Because remember, as Professor Seedy would say, replace the bad part with t. Infinity replaced with t over here. And let's write in terms of x as x to the power of 9 over, actually sorry about that, x over 8. Doesn't look much of an 8, but that's okay. Okay, so x to the power of 9 over here plus 3. Don't forget the dx. It seems to me that I can solve this using the u substitution method. And my u substitution appears to me is that u is equal to x to the power of 9 plus 3. And my d of u, which is the derivative of u, is x. Sorry about that. So 9 over x to the power of 8, and again a dx. So divide both sides by 9. 1 over 9 du equal to x over 8 du of x. And I put a check over here because I have my dx, x to the power of 8 and dx right there. Now I can plug back in my u, and I'll put my limit over here as t approaches infinity. I almost forgot. Because we're using u substitution, we have to change the bounds. So I'm gonna change the bounds right here. So u x to the power of 9. Sorry about, rewrite the 9 plus 3. So I would replace, I put my t over here to the power of 9 plus 3. For upper bounds, I could put u over here for upper. And for the bottom one, I can put u. So u is equal to 1 to the power of 9 plus 3, giving me 4. So let me put everything back in. So n is equals to so 4 is my bottom bound, and we have t to the power of 9 plus 3 as my upper bound. So, and my 1 over u and d of u. So now I'll continue to solve for the integral. I almost forgot. You know how we got 1 over 9 over here? We have to put the 1 over 9 over here. And the solving for the integral, we have 1 over 9 ln of absolute value of u. And don't confuse this one with don't confuse this one with this one right here, because it's completely separate. And this is showing the progress. And let's continue to solve. And 4 t to the power of 9 plus 3. This is the bound. We can rewrite it again to make sure we got everything right. So, but let's distribute the bounds over here. It's 1 over 9. So limit as t approaches infinity. 1 over 9 distribute our bounds. T to the power of 9 plus 3 minus ln of 4. Okay, so if you were to plug in our infinity into this one, basically we would have this gives you a divergent. So what we just proved is that our limit n approaches infinity n equals to 1. Infinity. Our original problem basically S3 is divergent. So we ask, what does this mean for the series? For the series of this one. Right? What does this mean? And that if we bring back our paper, and that the integral test, the conditions say that if an integral from 1 to infinity of f(x) of dx is derivative, then the series is also derivative. Sorry, not derivative, divergent. So we can say that our series, n equals to 1, infinity, n to the power of 9 plus 3 is divergent. By integral test. for a quick summary, we replaced the bad part with t. So we took from n to the power of n to the integral to the, from 1 to t, x over 8 over x to the power of 9 plus 3. And then we used the u substitution to solve for that. And we took that integral to the limit as t approaches infinity. We were able to get a divergent. This tells us about the series, that the series is also divergent. We know that from the integral test. So this is the solution. Thanks for watching.